Next we will discuss 11.2, that is the period of trigonometric functions. All the trigonometric functions show a periodicity. That means for a certain value of the theta, their value becomes similar. So the period of a trigonometric function is the smallest positive number which, when added to the original circular measure of the angle in theta in degrees or radians, gives the same value of the function. And we already know that for sine and cosine, theta plus minus 2 pi theta gives us the same value. So this is called the periodicity. So sine function or sine theta, if we see the graph, it's a periodic function and its period is 2 pi. So every plus minus 2 pi, it gives the same value. So this is the theorem. The proof is that suppose p is the period of the sine function such that sine theta plus p is equal to sine theta. Now put theta is equal to 0, we have sine 0 is equal to p, and this should give us the value of sine 0. And then sine p is equal to 0 and p is 0 plus minus pi plus minus 2 pi or plus minus 3 pi. But we see that if we put the p is equal to pi and check for any time that sine theta plus pi is equal to sine theta, it is not true. So pi or sine theta plus pi is equal to minus sine theta, this is also not true. So pi is not the period of the sine theta. If we put the p is equal to 2 pi, that is sine theta plus 2 pi, its value will be equal to sine theta, which is true. That means the periodic function or periodicity of the sine function will only be at plus minus 2 pi. We can see this in the graph that shows us animation. Let's see. Here you can see two sine waves. One is in the blue color, that is the constant, and the red one is moving. You can see that after only the 2 pi interval, it will superimpose again. So showing that after the 2 pi value, the sine theta will have the same value. So let's see. This line is started from minus pi 2 and is traveling to minus pi, then minus pi 2, and then when it reaches the 0, it superimposes, showing that the difference is 2 pi theta. That gives us a periodicity or the same function where the graph superimposes. Now we have we have seen that it has traveled from 0 to pi over 2, and it will superimpose the blue graph on 2 pi. And let's see, it's traveling on pi, it is not superimposing, and at 2 pi you can see that it will match the blue graph. Similarly, from 2 pi it's coming back, and when it will reach 0 value, it will be superimposed on it. This is showing that the periodicity is 2 pi. Again you can see it's from 0 to traveling back, and when the red graph will reach minus 2 pi, it will superimpose perfectly. So you can see here, this is showing us the periodicity. It is 2 pi, minus 2 pi to 0, and 0 to 2 pi. So its value of the graph changes from 2 pi value. Theta plus minus 2 pi gives us the same value. So the period of the sine graph is 2 pi. So this graph is showing the cos function. There are two graphs actually, and one is superimposed on the other. You can see that the blue is constant one and other will move, and you can see that from minus 2 pi to 0, the red line is showing the periodicity. So the periodicity or the theta value where the cos becomes the same value will be plus minus 2 pi. So you can see after traveling the 2 pi difference, the graph will superimpose. We will start it. So you can see the minus, the black graph is traveling, and when it will reach zero value, so there will be superimposition and showing that the periodicity of the cos function is 2 pi. So again we start it from 0. Let's see. From 0, the black graph will move, and when it will reach the 2 pi, it will superimpose on the blue function, stating that on 2 pi value, the graph will have the same, the cos function will be the same value. So for a difference of plus minus 2 pi, the cos function has the same value. That's why the periodicity of the cos function is 2 pi, plus minus 2 pi. Let's see. It's traveling from 0, and when it will reach the 2 pi value, the whole graph will, black graph will superimpose on the blue one. You can see. And coming back from 2 pi, when it will reach the 0 value, it will again superimpose, showing that the periodicity is the 2 pi. That means for every 2 pi, it will have the same value. So let's see, it's coming back, and when this curve will approach 0 value of x, it will show the y value of 1 as in the blue graph. And then it's coming back, and again from 0 to minus 2 pi, it's showing the periodicity. So cos function has also a periodicity of 2 pi, plus minus 2 pi. ये हम बात करते हैं टेंजेंट थीटा की, जहां साइन और कॉस थीटा और उनके रेसिप्रोकल सेकेंड कोसेकेंड का पीरियोडिसिटी 2 पाई के ऊपर है, प्लस माइनस 2 पाई रेडियन के ऊपर या प्लस माइनस 360 डिग्री के ऊपर है। तो टेंजेंट थीटा के लिए हम देखते हैं कि टेंजेंट थीटा जो है वो कि उसकी पीरियोडिसिटी क्या है। यहाँ पे आपको ग्राफ नजर आ रहा है, इट्स इन अ ग्रीन कलर, लेकिन इसके साथ दूसरा ग्राफ भी है जो इसके ऊपर सुपर इम्पोज हुआ है। हम देखेंगे कि वो चल के वो दोबारा जो है इस ग्रीन के ऊपर वो कैसे आता है और वो कितना जो है वो फासला तय करता है। सो लेट्स सी, आप देख सकते हैं कि रेड ग्राफ जो है इट्स मूविंग फॉरवर्ड, और कि कितने फासले के बाद ग्रीन अगले ग्रीन ग्राफ को सुपर इम्पोज करता है, और ये रेड लाइन जो शो कर रही है वो वैल्यू। सो एवरी पाई वैल्यू इट इज superimposing the green graph, showing that the periodicity is pi, not the 2 pi. So the tangent has a periodicity of pi. Again, it's coming backward. You can see the difference between 0 to pi, and the blue graph is superimposing the green graph. So for every pi value, there is a periodicity of the tangent function. Similarly, the cotangent function also shows the periodicity of pi. So this means that sine and cos and their reciprocal have a periodicity of 2 pi, while tangent and cotangent have a periodicity of pi.